Hi there, we're going to do some solving of quadratic inequalities. But before we do that, before we talk about that at all, I want you to solve these quadratic expressions by factorising them, please. So I want you to pause the video, factorise and solve these quadratic equations, and then come back when you're done. Okay, we have unpaused, so let's have a look. Right, first thing you need to do, and this is relevant to today as well, is to find factor pairs of C. Remember that number that's on its own at the end. This could be 1 times 12, it could be 2 times 6, it could be 3 times 4, but we're after negative 12, so it could be that we're after the factor pairs where the first number is negative, or maybe the second number. They can't both be negative. Otherwise, a negative times a negative would make a positive. So only one side is negative. Now, one of these pairs will add up to make the coefficient of this number here, which in this case is 1. We don't usually write the 1, but if there is an x on its own or a letter on its own, we know there's one of it, which is positive 1, and it's going to be this one here, because negative 3 and 4 have a difference of positive 1. And so we put them into brackets. Let's put x, take away 3, and let's put x plus 4. And it's important to say that you could do those either way round. It doesn't matter as long as the 3 is negative and the 4 is positive. And then you're going to try and make each of those brackets equal 0, one at a time. And this one will happen when this is positive 3, when x equals positive 3. And then we'll make the other bracket equal 0. And that's going to happen when x is negative 4. So the two answers are x equals 3 and x equals negative 4. And for this one, well, firstly, we need to actually rearrange this because we want the whole equation to equal 0. So I'm going to add 7 to both sides, because 7 take away 7 leaves nothing. And then this side will then be x squared, take away 8x plus 7. You need to rearrange it so it's basically all on one side, equaling 0. That's how we solve quadratic equations. And then again, so factor pairs of 7, well, that's quite straightforward, isn't it? 1 times 7. Now 1 times 7 makes 7, but 1 plus 7 doesn't make negative 8, this coefficient of x here. Remember, coefficient is just a posh name for the number touching the letter. This is that weird one, isn't it? This is the slightly odd case where both the numbers must be negative, because a negative times a negative makes a positive here, but negative 1 take away another 7 makes negative 8. So this is the pair of numbers we're after. Let's put them in some brackets then, double brackets. X take away 1, x take away 7, that equals 0. So we factorised it. And then to solve it, you want each of the contents of each bracket to equal 0. This one will happen when x equals positive 1. And this bracket will equal 0 when x equals 7. Basically, just take that bracket, write it equaling 0, and then make it equal 0. So the solutions to this top equation is when x equals 1 and x equals 7, that it will work. Yeah. Okay, now that is relevant to today, but we're going to look at quadratic inequalities. Now, inequalities. This is no longer something that equals something else. This is an inequality here, so x squared plus 2x take away 15. That's a pretty standard kind of quadratic part. But look, it's greater than 0. It no longer equals 0, it's just greater than 0. And what's the difference between the solution of an equation and an inequality? Well, I want you to pause and have a little think. What is the difference? Just have a pause, have a moment of thinking. Don't necessarily need to write it down. Okay, had a moment, paused. Okay, what is the difference? Well, this is it. An equation has only fixed answers. So those two equations before both had a pair of answers, just fixed numbers. An inequality has a whole range of answers. Okay, so that would be the difference between, say, x equaling 5, that's just, one solution, or x being less than 5, which is what this sign means. You will need to know today, that the less than sign, the more than sign, the less than or equals to sign, or the greater than or equals to sign as well. This has a whole range of answers. Basically anything less than 5 would be suitable. That could be 4, 3, could be 1.78213, it could be pi. Pi is less than 5. It could be anything really, as long as it is less than 5. So you can see it's a whole range of answers. But let's have a look at this quadratic inequality and let's solve it. Now the first part of this is exactly the same as before, with either factorising or, if necessary, using the formula to work it out. But all of the ones we're doing today you can factorise. Now factor pairs of 15 would be 1 and 15 and 3 times 5. But we're trying to make negative 15, so we know it could be that the first number on each pair is negative, or maybe it's the second number in each pair is negative. All of those pairs will multiply together to make negative 15. But which one adds together to make this coefficient of x, which is positive 2? Well, these two have a difference of positive 2. When I do negative 3 and I add 5 to it, I get positive 2. So that would be my equation factorised, or yeah, my inequality factorised, I should say, shouldn't I? Because it's not an equation, it's an inequality. And this is all greater than 0. Just use the sign you're given. Now at this point, I'm going to change to a different colour, because what I'm doing is going to kind of imagine that this was an equals sign, and I try and find the two roots of the equation. Try and just solve it briefly. So x minus 3 equals 0. That's going to happen when x equals positive 3. X plus 5 equals 0, which is going to happen when x equals negative 5. Now those are not the solutions to my equation, because my equation doesn't equal 0. It is greater than 0. Right. Now the best way to then do this is to actually just draw a small graph. Usually I would just sketch a little graph under here like this, but I'm going to show you for this first one, or first two maybe, I'm going to show you exactly what the graph looks like. Right. Oh, I forgot we had a little checklist. Yeah, so the first thing is factorise the expression, find the roots, so basically solve it. Now these are my roots, the x plus 3 and x minus 5. And then draw a rough sketch of the graph. That's the point we're up to now. Well, actually, I'm going to show you what the graph looks like, and see if you can spot where x is 3 and x is negative 5 comes into it. Yes, look, there is x is negative 5, and here is x equals 3. They are the 2 points where it goes through the x-axis. That's why we need these 2 points. And actually, if I was sketching this, I would do this. All quadratic graphs basically do a smiley face. Now some do an upside down smiley face, but all the ones we're looking at the moment will have a regular smiley face. And what you do is you just sketch your graph there, just do a couple of axes and put in the points that you've got there. So x is 3 and where x is negative 5, and just draw a smiley face graph through those points. Let's just go back to my blue. And it doesn't really matter if it's accurate as long as it goes through those 2 points and it's a smiley graph, yeah? Because all you want to know is which bits of the x-axis you're going to need. I'll show you what I mean. Now, go back to the start of this. Our equation, or sorry, an inequality, says that the left-hand side is bigger than 0. So we're after all the bits on the y-axis where it's above 0. Well, that's all of this bit here, isn't it? Going up there. So the bit of graph that we're after are the bits that are above the x-axis. So this leg over here is above the x-axis, and this leg over here, oh dear me, this tablet's really hard to use. That's my excuse, and I'm sticking to it. We want that bit of the graph there. We don't want the middle bit, because this bit is like under the ground, isn't it? It's under the x-axis, and we only want the stuff that is greater than 0. So in that case, we are after, if I go back to my blue pen, we're after all the bits of the graph this side. I've just changed my highlighter to blue. Well, let's stick with it, why not? And we're after all the bits of the x-axis that are this side of the 3. Can you see? Because look, my graph is that side of it, and my graph this side is that side of the minus 5. I don't want the bit between negative 5 and 3. So when I'm writing my answer, I would write my answer as, let's go back to the pen, write my answer as, it's going to be 2 parts. So first of all, we want everything that's below minus 5. So x is less than negative 5, and we want all the bits where x is bigger than 3. So x is bigger than 3, and that there is the solution to it. It's a range of answers, anything less than minus 5, anything bigger than 3. Yeah? So what did we do? We first of all factorized the expression. We then found the roots. We basically solved it, pretended it had an equal sign just to get the 2 points where it goes through the x-axis. And then we drew a rough sketch of the graph. So we put on those 2 points, just did a smiley face through it. And then we decided which parts of the graph we want. And then we wrote the answer as an inequality. So we know we want the stuff above the x-axis. Well, that happens when x is less than 5 and x is greater than 3. All right. Sorry if I'm repeating myself a lot, but I think it's a good idea just to kind of reiterate what we're doing. Right, don't worry, we're going to do another example before I let you loose. Okay, first thing then, factorize the expression. So you just do your factor pairs for this, which is, 1 times 12, 2 times 6, 3 times 4, but it's negative 12. So it could be that the first number in each pair is negative, or maybe we'll do the pairs again, where the second number is negative, but only one of them can be negative. Now, one of these pairs of numbers that multiplies together to make negative 12 will make positive 1. Which pair is it? It is this pair here. So negative 3 and 4. Put those together and you get positive 1. So if I factorize my expression, I get x, take away 3, and x plus 4. And then use the sign that you've got here. So this is less than or equal to 0. Okay? Ooh, oops. Oh, let's go back. What happened? Sorry. Bit confusing there. Sorry. Oh, anyway, I do hate when things like that happen. Anyway, we found the roots. So let's draw a rough sketch of the graph. Now, again, I've actually got... Oh, no, I haven't. Oh, computer, stop doing that. Draw a rough sketch of the graph. So let's draw a rough sketch of the graph, and you literally just need your axes, and you put in the 2 points that you're just about to find, because you need to solve it. Well, x minus 3 equals 0. So we're going to pretend that it equals 0. We know it doesn't, but it's a good way of just finding those roots of the graph. Okay, let's just neaten that up a bit, because for some reason I wrote 4 plus 4. Didn't mean that. I meant x plus 4, didn't I? Oh, come on, pen. Well, today's going well, isn't it? X plus 4 equals 0. So take away 4 from both sides. X equals negative 4. Yeah? So mark those 2 points on. So positive 3 and negative 4. And then just draw a smiley face graph coming down through those 2 points like that. And then look at the sign. What sign have we got here? We have got less than or equal to 0. So particularly it's less than 0. That's what we're after. So we are after the bit of the graph. I'm just going to get the red pen here. We're after the bit of the graph that goes under here. Anything less than 0. And when it says less than or greater than 0, it means the x-axis. If it's less than 0, it's below the ground here. If it's above, it's up the top of above the x-axis there. So we're after the bits between negative 4 and 3. So if we are writing out our inequality, x is bigger than 4. So x is bigger than 4, but it's less than 3. But this is the point. You need to look at the sign, the original sign you're given, and it's less than or equal to. And if it's got that extra line, then you need that extra line as well, because actually it includes the points of negative 4 and 3. So what did we do? We drew a rough sketch. Let's go back to blue. We drew a rough sketch. We decided which parts of the graph you wanted. So that's either, you either want the bold bit in the middle, if it's less than, or if it's greater than, obviously we want the bits sticking up. And then decide which bit of the graph you want. And we wanted the bits between there, didn't we? I just sort of highlighted it in red, the bit underneath the graph. And then write your inequality. Yeah. Just keep an eye out for that extra sign though. If you need the extra little, equals to, then put that in as well. And then wrote the answers in inequality. We did that. Okay, right. I think after all that talking, it's your turn to have a go. So unpause. Oh, not unpause. Pause. Factorize, pretend to solve it, draw a little sketch, and then try and write the inequality. Really, just have a go at it, even if you're confused. Don't just look at my answer straight away. Do have a go first, okay? So pause now and have a go. Okay, right, so hopefully when you've factorized you should have got that graph. Oh, whoops, let's go back to that. You should have got x minus 5 and x plus 2 as the factor pairs that you're after. That makes -3. And when you did your solutions, you should have got x is +5 and x equals -2 as your two roots of the equation, all right? But only if we pretend that it equals 0. Then you're going to sketch your graph out. And we've got the points of, well, that's not very accurate, let's put it there, -2 and 5. And you really don't need to be very accurate with this. It just needs to be a smiley graph going through the points you said. So it comes down through -2, back up through 5. So factorize, find the roots, draw a sketch, decide which parts of the graph you want. What does our sign say here? It says greater than or equal to 0. So the bits of the graph that we're after, and it does help to show this in another pen, is that bit there, because that's the bit that's greater than 0. It's above the ground, isn't it? It's above the x-axis. That's where y is greater than 0, which means we're after the x-axis this side of -2 and this side of +5. So if I was writing my inequality, let's go back to my blue pen. This has to be a two-part inequality because we've got two distinct sections, the bit over here and the bit over here. It's not joined together. So x is less than -2, but actually it's less than or equal to. And we've also got x is bigger than 5, but of course it's bigger than or equal to because my original sign was bigger than or equal to. Yeah? Okay, getting the idea? Just remember, follow your little checklist. It does make things a bit easier. Try another one. Okay, so pause the video again, have another go. Look at the sign, just be careful. Think of what you got wrong last time. If you got something wrong, how can you not get it wrong this time? Yeah? Okay, off we go. Right, we've unpaused then. So when you factorize the expression, which is the first thing on your list, you should get x plus 4, x plus 2. Remember, these could be either way round. It makes absolutely no difference at all. Then you find your roots. And in this case, it's x is -4 and x equals -2. So they're both negative. And then next bit, draw a rough sketch of the graph. So there's my y-axis. There's my x-axis. Now, both of these numbers are this side of it. So -4, -2. And then draw a rough graph just coming down through that. So a smiley graph coming down through those 2 points. A little bowl in the bottom going up. See, inaccurate. How inaccurate is my graph? But it doesn't matter. It will still work. And then let's have a look at the next bit. What do we do next? We decide which parts of the graph we want. So look at the sign. It's less than 0. So that means the stuff below the x-axis, the stuff below ground level, which is the little bowl, which means we're after the bit between those 2 points, aren't we? So my inequality could be written as a single straightforward inequality, like a double-sided inequality. So x is going to be bigger than -4. So, you know, the side of the inequality sign is next to the x to show that it's bigger, but it's less than -2. Look at the sign. Is there the extra equals bit too? No, there isn't. So my answer doesn't have that either. All right, so x is bigger than -4, but less than -2. Yeah? Good luck. Right, okay. 4 questions for you to do. This is the main bit at the end here, okay? Have a go at these 4. Do the things, you know, go through the checklist at the top here and unpause when you're done, and let's see if we agree. You could, of course, do one at a time, because I'll do the answers one at a time, so you can keep pausing between answers, up to you, but otherwise just do all 4. Off you go. Okay, we've unpaused. Now, as I said before, there's nothing to stop you doing one, looking at the answer, pausing it, doing the next one, pausing it, you know, do the answer and pausing it and keep stopping each time. I'm just going to run the answers through now, but you can pause as you like. You could pause me now if you want to. That was funny, wasn't it? No? Okay, let's move on. Right, let's factorize this first one then. You would get x minus 3 and x minus 4. Could be either way round. So if you do the the roots of the equation that you need are going to be x equals positive 3 and x equals positive 4. There's a picture of the graph. Decide which bit you need. Well, you want the bit that's below ground level, so you want this bit here, which means that your answer should be x is bigger than 3 but less than 4. Yeah, and it doesn't have the equals 2 bit. It's just between those 2 points there. Okay, move on to the next one then. So if you're factorising this one, you get x plus 2 and x minus 6. Could be either way round. Which means the roots of my equation are going to be x equals negative 2 and x equals positive 6. So there's my graph going through those 2 points. There's negative 2, there's positive 6. And decide which bit of the graph you want. So it's less than or equal to 0. So less than 0, it means it's in the trough, isn't it? It's in below ground level. It's all of this bit between these 2 points, which means we want the bit between there. Just like the top, we wanted the bit between there. So this could be written as a single inequality with x in the middle. In fact, I don't need to write it because I've already set that one up. Oh, come on, pen. There we go. So you should get x is bigger than or equal to negative 2, but less than or equal to 6. And remember, you need the equal to bit as well because your original sign had that. Okay, so moving on to number 3. When you factorise, you get x plus 4 but x negative 9. Either way round, of course. And the roots of your equation will be x equals negative 4 and x equals positive 9. So when you sketch your graph, it goes between those points. So there's the negative 4. There's the positive 9. Now, decide which bit of the graph you want. We want the bit that's bigger than 0, which means we want this leg up here that's above ground level, and this part of the graph over here that's above ground level. So we're after all the x bits that are that side of negative 4 and all the x bits that are that side of positive 9. So we need 2 separate inequalities, and they are x is less than negative 4 and x is bigger than 9. Yep. Okay, last one then. When you factorise this one, you get x is negative 4, x is positive 6. It's like the inverse of 1. Did we do that one earlier? Oh no, maybe we didn't. I'm talking rubbish. Ignore me again. Right, x is 4 for one root and x equals negative 6 for the other root. So draw a little sketch. And there's the negative 6, there's the positive 4. We've got a smiley face graph going through it. Decide which bit you want. Well, it's bigger than or equal to 0. So if it's bigger than 0, it's this leg that's above ground level over here, above the x-axis. And this one that's above ground level, the x-axis over here. So decide which bit my inequality is going to do. Well, obviously it's that side of negative 6 and it's that side of positive 4. So 2 separate inequalities, which are x is less than or equal to negative 6 and x is greater than and equal to 4. Because you need the equal to bit because my original sign also had the equal to part as well. So there we go, solving quadratic inequalities. It feels like you're doing real maths, doesn't it? It's quite fiddly, there's a lot to it, but just remember your checklist. If you can remember the sequence of stuff, each stage isn't particularly hard, it's just remembering all the stages. Okay, now if this is on a show my homework posting, there may be the option to do some extra questions if you want to, but I'll put that in the post itself. Otherwise, I shall see you next time, and well done!